Hello, so welcome along to this AQA Further Maths paper. What is the year? Is it year 2023, paper 1. Now, unlike my GCSE walkthroughs, I'll go through these in like intervals because otherwise the video is just too long. Also, I'm recording it on my iPad just because it's a little bit easier. I don't have to kind of edit anything. It's just quicker for me to do. So the quality, look, if you watch it on your phone, it's going to be absolutely fine, but it should be good. Now, this is a non-calculated paper, and what I'll do is I'll just go through it and look at the mark scheme as I go through, so we can check we're getting it correct. Okay, but let's just begin. So the first part. Question 1 is saying that you've got this function, 2x plus 1, f of x. F of x just means y, basically. It's just function notation, equals to 2x plus 1, and work out x when f of x, so when 2x plus 1 is equal to minus 5. So you're just going to go and write an equation that 2x plus 1 is going to be equal to negative 5, and then you're just going to solve that equation. So you're going to go and minus the 1 onto this side, so 2x is going to be equal to minus 6, and then divide it through by 2, so x is going to be equal to negative 3. Okay, and that should be the answer for the first one, and there we go. Good. We'll check it in a second for the mark scheme. Part B, you've got this function, g, so g of x is given by x squared, work out f g of 3. Now this is a composite function. What this is saying here is, right, forget the 3 for the time being, it's saying you've got the function f, and you're putting in the function g of x into f. So g of x is here, which is here, and you're going to go and put this into f of x. Okay, which is up here. So you replace the x here with g of x, which is x squared. So f g of x is going to go to 2 lots of x, and you're going to replace the x with x squared, and you've got the plus 1 on the end. So I've just put in x squared in for x in this function, because I'm putting g of x into f of x. Now let's just kind of go and simplify that. That would just go to 2x squared plus 1. Now, what the question is asking for f g of 3. So now you just go and put in 3 into your expression. So 2 lots of 3 squared plus 1. And 3 squared is 9, times by 2 is 18, plus 1 will give you 19. Okay, so my iPad is lagging a little bit. I'm not quite sure why, which is making it a little bit awkward, but that should be fine. So check the mark scheme, minus 3 and 19. Yeah, we're looking good. Okay, perfect. Good stuff. Question 2 is a factorizing. Now this is just a, it's not what it is quadratic, you can see here, but it's just, you're saying what goes into 6 and 21, the biggest factor is 3. So you can take out a 3. You can also take out an x from both of those there, and you can take out a y, and open up a bracket, and 3 times by 2x would give you 6x squared y, and then you want 21xy, or 3 times by 7 would give you 21, and 3xy times by 7 is 21xy, so that should be the answer. Okay, so 3xy, 2x plus 7. Check the mark scheme. Good, we're looking good. Okay, question 3a is saying circle the transformation that represents a reflection in the line y equals to minus x. Now when you're looking at matrix transformations, you can remember there's 8 of them you need to know for further maths. You can just memorize them, but actually that's not always the best option. If you forget how to do a transformation, you can draw out your unit square. So what I mean by that is you can have a square across by 1 and up by 1 like this. And we're always going to refer back to the identity matrix. Now the identity matrix I is your matrix, which is 1, 0, 0, 1. And you can think of this as, well, this one up here is an x coordinate and this 0 is a y coordinate. Now you've got to think, if you were to reflect this unit square in y equals minus x, or first of all let's just go and draw that line on. Y equals minus x will be going like this. Okay, so that is the line, y equals to minus x. You've got to think about how these points here change. So the point 1, 0, okay, that is this point down here, 1 across, 0 up and down. If you reflect it in this blue line here, that's going to go and end up being this point. It's going to reflect to go down here, which is going to be the point 0, minus 1. So the point 1, 0 would actually end up becoming, that would go to down here, which would be 0, minus 1. So we can go and change that to become 0, minus 1. And then similarly with this point here, you've got x being 0, y being 1, which is this point here. If you reflect this point along this line here, it will go down to over here, which would be minus 1, 0, the coordinate. Okay, so it's going to be minus 1, minus 1, and then 0. So which one of these is it going to be? The first one. Yeah, that's the transformation represented by a reflection in this line. Good. Part B, show that this matrix multiplication is K times by the identity matrix. Now let's just go and consider the left-hand side of the equation and go and times those together. So if we do that, let's just go and write it in this matrix. When you times matrices, you do it like this. You take the first row with the first column, and we go and do 2 times by minus 3, which is minus 6. And then you go and do 4 times by 1, which is plus 4. That's going to be the first number in your matrix C. Now let's just go and actually make this a little bit bigger, otherwise it will get too small. There we go. And then you take the first row with the second column. So we go now first row with this one. So you go and do 2 times by minus 4, which is minus 8. And you go and do 4 times by 2, which is plus 8. And that's going to be useful. That's going to go to 0. And then you go and do the second row with the first column. So you've got negative 1 times by negative 3, which is plus 3. So 3. And then you've got negative 3 times by plus 1, which is negative 3. Sorry, so 3, take away 3, that will go to 0, which is useful. And then you go and do finally the second row with the second column. So negative 1 by negative 4, which is plus 4. And then you've got negative 3 times by 2, which is plus 6. Sorry, which is minus 6. Minus 6. Okay, good. And then you can just go and simplify this. So that's going to go to minus 2, 0, 0, minus 2. And this is really good because now I can go and factorize out a negative 2 from the matrix, because then it will go to 1, 0, 0, 1. Because this here, the I represents the identity matrix, which is 1, 0, 0, 1. And negative 2 times by 1 minus 2 by 0 gives you 0. Times it with 0 is 0 minus 2. So K in this case is going to be equal to minus 2. So I've shown that if you times these together, you get the identity matrix times by a constant value, which is 2. So my microphone is falling over. So K is minus 2. Okay, but I've already shown that in the question, so that's fine. Good. And let's just go and check the mark scheme. So 3A, good, and then 3B, yeah, we can see they've got the minus 2. Good. Okay, how long have I been going for? I'm just wary that I don't want to make it too long on these videos. 10 minutes, that's fine. Question 4 looks like a straight line question. It is. So point S and point T are points on a straight line. Work out the gradient. Now the gradient is simply the change in the y coordinates. So the y coordinates here are minus 4 and 2, and you take them away, so you go and do minus 4, take away 2, over the change in the x coordinates, well, it's 5 and 7, so we go and do 5, take away 7. That's going to give you negative 6, minus 6 over minus 2, and which gives you just 3. So that's your gradient, which is going to be 3. There we go. Now work out the distance between the points S and T. So S is here and T is here. Now, you can use the equation here, but just to show you visually what is going on with this question, if you just kind of really roughly go and plot what's going on, okay, you've got the point S, which is going to be somewhere over here, and that's got a point 7 and then 2. And you've got T, which is 5 minus 4, somewhere kind of down here. That was just a really rough sketch. 5 and a minus 4. Now, distance is basically, right, you want this part here, okay? And then to get this, right, you can go and consider a triangle like this. And you're really saying, well, from this distance here, you're going from 5 to 7, that's going across by 2. Okay, across by 2. Ooh, and you're going to be going up by, from minus 4 to 2, it's going up by 6. So it's going to be Pythagoras, because you've got a right angle triangle, and you want this point up here. So it's going to be 2 squared plus 6 squared rooted. But to do this more quickly, right, what this really is just saying is, well, to get ST, you can just go straight into saying, well, it's going to be the difference between the x coordinates, so 7 take away 5 squared, which gives you the 2, and you're going to add on the difference between the y coordinates, which is going to be 2 take away minus 4 squared, which is where you get the 6 from. Okay, so st is going to be equal to the square root of, the first bit is 2 squared, which will give you 4. The second part would give you 6 squared, which is 36. Okay, so there we go. That's going to go to the root of 40. Now, just read the question carefully. It's saying, give your answer in the form a root b, where a and b are both whole numbers. Now, root 40, you can simplify because we can recognize that root 40 is going to be equal to root 4 times 10. And that's good because, well, root 4 gives you 2 times root 10, so 2 root 10. And that should be your answer, okay? Unless I made a mistake, but that should be fine. Where a is 2 and b is root 10. Let's just go and check the mark scheme. So we got 3, didn't we? And we got 2 root 10. So that's looking good. Good. Question 5, here we go. X, n, and y are both nth terms of 2 sequences. Okay, there we go. Prove that every term in a sequence with the nth term y take away xn is a multiple of 3. Now, to prove it's a multiple of 3, you're going to have to end up by factorizing out a 3 from something, because 3 times by anything will give you a multiple of 3. And it's 3 times by a whole number, an integer, will give you a multiple of 3. Now, what I'm just thinking to go and do here is, before I take these away, expand the brackets. Okay, so let's go and consider xn first of all. Now, actually, xn, I recognize, is in the difference of 2 squares form. So that's in the form a plus b. So it's really laggy, which is not good. Anyway, you've got a plus b, a minus b. Now, that will expand to give you a squared take away b squared. So in this one, what a is n, so it's going to be just n squared. Take away b squared, will b is 1, so take away just 1 squared, which is 1. So if you expand these brackets, you get to this here for x of n. And then for y, n, similar sort of thing, go and expand the brackets. So if we go and do that, well, it's going to write it all out. So n plus 1, n plus 2. If you expand the brackets, it will go to n squared. I'm going to go and do it in one go, but you can go through the process here. It's going to be 2n plus 1n, which is 3n. And then 1 times 2 gives you plus 2. Now, you want to go and do yn, which is this part here. So n squared plus 3n plus 2. And you're going to go and take away the n squared minus 1. Let's just see what happens. There's going to be some cancelling out. So if you take these away, these are going to cancel out, becomes 0. And you're going to be getting, well, 3n, take away just nothing. There's no more n's here. We'll just leave you with 3n. And then you've got 2 take away negative 1, which give you plus 3. So 3n plus 3. And that's good because now I can take out a 3, factorize out a 3, and n plus 1. And this will give me a multiple of 3, because 3 times by any whole number, because n is an integer. Okay, it says that in the question, it should do. Yeah, that's fine. 3 times by any number will give you a multiple of 3. So just got to go and write that. So 3 multiplied by an integer will always be a multiple of 3. Okay, and that should be good. Let's just check the mark scheme, but that should be absolutely fine. So we're looking for 3n plus 1, which we got good. Okay, let's do maybe one more question. Question 6, you've got the equation of a curve is given by this here. So this is some sort of curve. Work out the equation of the tangent to the curve at the point 1, negative 2. Now this is a classic differentiation question. So what the question is really asking for, this thing up here is some sort of curve like this. Could look like anything. Now let's just imagine that this is the point 1 minus 2 down here. Just a sketch. You want the equation of this line here. Now to get this, you need a couple of things. Well, you need the first thing, which is you need the gradient at this point, at this particular point. And to get the gradient from a function, you differentiate. Differentiate tells you the gradient at a particular point. So let's go and take the derivative, the first derivative, dy by dx, of our function. Now when you differentiate, you times by the power and you reduce it by 1. So the first term will go to 6x to the power of 5. You then take the 2 up here, you times it by 4, which will give you 8, and you reduce that power by 1 to give you plus 8x. And if you differentiate just a number, a constant term, it goes to nothing. So that's the derivative. Now you want the gradient at the point x being 1, because this coordinate here, the 1 is your x coordinate, and the minus 2 is your y coordinate. So to get the gradient at the point 1, x is 1, you can write it like this. So you can say dy by dx at the point x being equal to 1 is going to give you substitute in 1, so 6 times by 1 to 5, plus 8 times by 1, and that's going to give you just 14. So actually, this is saying the derivative at the point x is 1, which gives you the gradient, is 14. So now you can go and say that, well, the gradient m equals to 14, and you've got the coordinate 1 minus 2, okay, which has got an x coordinate and a y coordinate. You now just go and whack it into y equals mx plus c, because the question wants it in this format. So you know that y is minus 2 is equal to m, which is 14, times by the x value, which is 1, plus c, and then we just go and take away the 14, so c will be minus 16. So the equation of your line is going to be y is equal to 14x, where 14 is your gradient, take away 16. And that should be the answer. Let's check the mark scheme. There we go. So 14x take away 16. We're looking good. Perfect. Maybe one more question. Let's have a look at this one. So I've got a new microphone that keeps falling over. Hopefully it's good sound quality. Question 7 is, you've got below a cone and a prism. The cone has base radius r, and the prism has got a triangular cross-section with base y and height y. The length of the prism is x. Okay. The volume of the cone is 4 times, so this is 4 times the volume of the prism. Express r in terms of y. So that might seem really confusing. At first, I'm not quite sure how this will work out, but let's just go and find the volume. We're talking about the volume here. So go and find the volume of each shape. Now, the volume of the cone, you're given the formula, so that should be quite okay. The volume of the cone is going to be equal to 1 over 3 times by the base. Now, the base here is a circle, so pi r squared. Okay, there's no value of r, but keep it in terms of r, so times it by pi times the radius squared. And the height of it is just going to be x, so x. Now, actually, these dots here, these aren't decimals. When you start to do high-level maths, dots are used to represent a multiplication sign. So a third times by pi r squared times by x. Now, that's going to get the volume of the prism. Okay, now the volume of a prism is the area of the face, okay, the cross-section, and you times it by the length. Now, the area of the face here, you've got a right-angle triangle. It's going to be y times by y, and then divided by 2. So that's the area of the face. So y squared over 2, and you're timesing it by the length, which is x. Okay, so you can really just write that as x y squared over 2. Now you know that the volume of the cone, which is 1 over 3 pi r squared x, is going to be equal to 4 times the volume of the prism, which is x y squared over 2, like this. Now, this 4 divided by 2, I'm actually just going to go and simplify straight away. 4 divided by 2 just gives you 2. So let's go and kind of rub this out and just write it as 2x y squared. Now, we can do some cancelling out here, because I can see, well, first of all, actually, right, we've got this dividing by 3 here. I'm going to times the whole equation by 3 just to get rid of that. It's a bit of a pain there, so it's times everything through by 3. So you're going to go to pi r squared x is equal to 6xy squared. Now, I recognise that I've got an x on both sides, which they will cancel out if I divide through by x. And then I want to get r in terms of y, so I'm actually going to go and divide through by pi and then square root. So I can say, just kind of doing it in one step, that r, if I divide through by pi, you're going to get 6y squared divided by pi, and then to get rid of the square, you're going to square root everything. And really, it could be plus or minus, but probably not minus, actually, because it's a radius, it's a length. So keep it positive. And this is the radius expressed in terms of y. So 6y squared over pi. Let's check the mark scheme. Good. We're looking good. Okay, and I'm going to leave it there for the time being. that is part one of the June 23 paper one.